Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. 2-phenylpropene is C6H5-C, CH3 is equal to CH2, i.e., an alkene with a phenyl group and a methyl group on the same carbon, C2, with a terminal double bond, C1 is equal to C2. The target molecule has the structure PHC is equal to CH2, CH3. Moving on to the next step. 2-phenylpropene is equal to PHC, CH3 is equal to CH2. This is a trisubstituted disubstituted alkene where the double bond carbon bearing the phenyl group also bears a methyl group. Moving on to the next step. Working backward via dehydration, the precursor alcohol would be PHC, CH3 of CH3, i.e. 2-phenyl-2-propanol, a tertiary alcohol. Dehydration of this tertiary alcohol with H2SO4 heat would give 2-phenylpropene via E1 elimination, Z-CIF product, and the only possible alkene from a symmetrical tertiary alcohol here gives PHC is equal to CH2, CH3. And for the final step, react phenyl magnesium bromide, PHMGBr, made from bromobenzene plus Mg in diethyl ether with acetone, CH3, to C is equal to O. The Grignard reagent, PHMGBr, adds to acetone to give, after H3O plus workup, PHC, CH3, 2O is equal to 2-phenyl-2-propanol. Treatment of 2-phenyl-2-propanol with H2SO4 and heat causes dehydration to yield 2-phenylpropene, PHC, CH3, is equal to CH2. A. Friedel-Crafts alkylation of benzene with 2-chloropropene and UlCl3, the allylic carbocation from 2-chloropropene would rearrange, and the alkylation product would not cleanly give 2-phenylpropene. This is not a reliable synthesis. B. Benzaldehyde plus ATMGBr gives PHCH, or CH to CH3, a secondary alcohol, 1-phenyl-1-propanol. Dehydration would give PHCH is equal to CH, CH3, 1-phenylpropene beta-methylstyrene, not 2-phenylpropene. C. PHMGBr plus propanol, CH3CH2CHO, gives PHCH, of CH to CH3, secondary alcohol. Dehydration gives PHCH is equal to CH, CH3, not 2-phenylpropene. D. PHMGBr plus acetone gives PHC, CH3, 2O. Dehydration gives PHC, CH3, is equal to CH2 is equal to 2-phenylpropene. Correct. Therefore, the correct answer is D. Therefore, the correct answer is option D.